Welcome to another beautiful Friday, slightly earlier than usual, but that doesn't matter for people watching the recording because it's always on. But we have our wonderful special coworker and friend and esteemed guest of honor, Alex Ioffe, to tell us about his phantasmagorical library Quill, which allows you to do anything you want with databases with limited boilerplates, and it works elegantly with Zio and basically every other library in existence. It is the nexus of all libraries, and his brain has to bear that complexity, and it's grown quite large. And he will share some of the pearls that have formed in his brain with us. Introduction.
Thank you. Thank you. Thank you so much. Yeah. There was a quote that a rabbi once said in response to some very wonderful introduction that someone did to him. He said, "Thank you so much. I wish my parents were here to say that. My dad would be proud. My mom would actually believe it." So thank you so much for the wonderful introduction. So what Quill does is Quill essentially takes all of these elephant and dolphin and wireframe mesh thing and big O and various other things representing Postgres and MySQL and SQL Server and Oracle and H2 and SQLite respectively, all of these wonderful culprits, and actually brings them into the world of functional programming. That is what Quill does. Also, there's a bunch of other databases that Quill does interop with, most notably Cassandra, also Spark, and we've got a couple others as well, like OrientDB. So the question is, how do we bring databases into functional programming? And as a summary of everything I'm actually going to go through in these slides, basically it's this, where what we have is we start with some SQL that we want to write, and we use it writing Quill's DSL, which is this query of a thing, and then we run it.
Oh, right? I only see the first slide.
Yeah, I think you may not be advanced the slides.
There we go. So, okay. So the idea is you call this run method. Actually, we have a .stream method for the streaming side. And then what we can do is we call .run or .stream, which is a little bit of a misnomer. Maybe we could change the semantics for that. Basically, the .run and .stream will give us a Zio that returns the things that are coming that we want from our query. So if A is a query of people, this will return an A, for example, or a list of A, like a list of people, or a particular person, depending on how our query is structured. And so what we can do is we can then sort of call .run on this thing, and this returns to us a Zio. And we can then use that, and then we can compose it further, and we can get compositional effects. And we can also do streaming that way too. So very, very, very cool. And it's a very simple way to go from a query that is basically encoded as Scala code to the Zio API. And then we call provide data source on it. So a data source is going to be most typically a Hikari pool, and there are some constructors to help you put that together. And hopefully we'll go through some of that in the live code. And so what we can do is we can provide a data source, and typically we can manage it as a sort of managed resource of some kind, but sort of you have all sorts of flexibility there. And you provide the data source, and then that gives you an IO that just either throws an exception or returns the result. Now, okay, we write some SQL, right? We have a query that yields rows of type of something. The Zio, right, it's a program. It's a program that computes a list of A or a single A or some amount of A's, or a stream that does that. And then...
I hear some tapping. Just want to validate, because I think the slide may be frozen again, unless you are still in the same slide.
Oh, is the slide frozen again?
Yeah, I don't know why. Yeah, write some SQL. Yeah.
And now the next one.
Query that yields rows of type A. Ha ha ha.
Working now. Okay.
Yeah. If you wanted to maybe start from this slide again, I'll splice it in.
Okay. All right. Let's start from here. Okay. So we start with some SQL, right? We then compose it into this query thing that we can then execute, and we can then run it. And then once we run it, or .run or .stream, we will get essentially a program that takes in this data source thing, which is a way of getting JDBC connections that will then let us plug that thing in once we run our application, and then yield a list of A's, or a single A, depending on what your query is. What's fun is that this data source thing for JDBC, it's going to be a JDBC data source. Quill supports other databases, like for Cassandra, this is going to be a Cassandra connection. So these can potentially be different things. So once we plug that in, then what we do is we get something that just can either throw an error or produce our result, or a list of results, and the same thing for a stream. And then that's what happens when we provide this data source thing. Right, the data source gives us our connection objects. Now, what's fun is that Zio makes sure that the stuff on the bottom half of the screen is composable and doesn't have side effects. Quill makes sure that the stuff on the top of the screen is composable and doesn't have side effects. So, brief bit of history before we go into it a little bit more. Originally, we it wasn't this. Originally, we had
really quickly to that slide of the people. I just want to take a quick screenshot of that. Not a cell phone in sight, just people, living in the moment. It's beautiful. The good old days. Sorry, thank you, Alex.
Yeah.
That's amazing.
Just an example of how we've had a little bit of sordid history trying to get the API right. Originally, it wasn't this, it was this. And the idea was, well, we need to indicate that this is a blocking API and that it needs to be a connection. And then we said, okay, we could use layers to try and make this nicer, and we can provide a layer constructed from a prefix, but the problem was that this constructor would construct the entire Hikari pool each time, and that was a problem. So we couldn't really do it like this. And then also we said, well, this connection with blocking thing is a bit of a mouthful, so let's call it Q connection, and then let's call the whole thing a QIO of A. And that turned out to be a serious mistake. We said, okay, fine, we'll provide this on data source thing that would properly use layers to inject the data source layer that would use the data source as a managed dependency. And then we would say, okay, we have this data source. And by the way, at the end, the data source has to be closable. And so we decided to put that into the API. So it has data source of closable with blocking. And we decided to call that QDataSource. And that was how you were supposed to do it. You're supposed to do .onds.provide and then provide the data source. And by the way, unfortunately, because has is invariant in some way, you would have to cast your data source as data source with closable, because data sources in their natural state are not defined as data source with closable. They're typically defined as Hikari pool. So you would have to take your connection pool and you'd have to some way cast it or sort of widen it to this kind of data source with closable thing, and then you could put it into a has. And And then we realized, okay, well, first of all, kind of want to get rid of the blocking part, because that will make things easier. And blocking can just be an indication. We can indicate to some other way that the Zio runtime is blocking. So, okay, cool. We got rid of that part. Oh yes, we mentioned that already, that you need to have a specific data source with closable. And then it's just, okay, we can actually remove the with closable part, because really the with closable part is only important when you're dealing with a Hikari pool. And typically you'll deal with a Hikari pool somewhere else, somewhere upstream of the issue. And typically the lifetime of the Hikari pool will be the lifetime of your entire application. So most of the time, we actually don't care about closing the pool. Most of the time, that's not really somewhere in your application's finalizer, it'll close the pool or something like that. So that's not really a concern here. So then we're like, okay, fine. So then just on DS, right? Because still our original API was has connection, and then on DS would convert from a has connection to has data source. And this is what we understood, that sort of we have this has connection thing, and you have to provide a connection from somewhere, right? Where's your connection coming from? Well, it's going to be coming from a data source. It's going to be coming from a connection pool. And so in 99% of cases, this is not a connection that you have floating around somewhere. You actually need to grab it from a pool. There are some situations where you're trying to deal with like legacy Java stuff. And if you're trying to use Zio inside of legacy Java applications, sometimes in those legacy Java applications, you'll have your connections coming from some managed resource that legacy application manages. But 90% of the time, you're going to be the one that's going to be making the pool. So this whole like as DS thing, that is just extra noise. So, and then on top of that, we realized that like this is more than just noise. This is an actual like stumbling block for users. And sort of this is part of the Zio creed, which is that when users are having problems with our libraries, we look inward. We look inward to ourselves. What are we doing wrong? And the answer here was very, very clear. The API that I provided, this has connection thing that was coming from the run and stream methods, it was too low level of an API. And so this, and I'm sorry about that. It took me a while to realize that this was a really big mistake of mine, but I realized it. And so what we did was in the last hackathon, this is what we went to. And this is where we want to be. This is where we want to be. And this was very nice. This was very nice that we went to this API. Thank you everybody who participated in the hackathon, by the way. Very, very awesome energy. And we did a lot of great work there. So thank you everyone for participating in that. So we realized, okay, this is has data source, no with closable, no connection, is just this. This is what it's supposed to be. This is sort of the best that we can do in Zio 1.0. In Zio 2.0, hopefully very soon it will be this. And that is all. That is all that we care about. In fact, the type alias QIO, it probably won't even be necessary. So we can just have this. So this is the best way that I know possible. This is the best way that I think this sort of thing can be done. So this is hopefully the API that we will have very, very soon. For now, it's this, which is simple enough. Now, yes, huzzah indeed. So I want to step back for a second. Why Quill, right? Like why Quill does composition. Quill does query composition using a Scala API, but why, right? Like SQL is easy, right? This is an example. This is a doobie example, but it might as well be Jdbc. It might as well be any other kind of system. This is right. You just write your SQL string and that's fine, and that sort of works. Why do we need more complex things? Well, okay, right. The query is expected to yield something that has that kind of structure. Okay. And if it doesn't yield that kind of structure, it's a problem, but we have to test it. And we only know at runtime whether this will actually work or not. And okay, fine. We don't have a problem with SQL injection, because what we could do is we can have some kind of interpolation operators that do fun things that don't splice the string directly. Like that's not an actual problem. But okay, we can then yield other objects like actual product types coming out of it, and because they're structurally equivalent. Now, okay, but what if we mess up the order of the fields? Or in fact, what if we mess up anything in this string, right? We only know about this problem during runtime. We only know about it during testing, right? This is, in fact, you can even go one step further and you can mess this up in the tests, right? Because here's the thing. If you're using this kind of select field thing, you could get it wrong both in the insert and in the read. So you can actually get it wrong all the way through. And then of course the fact that these are all strings, you actually like need to test what the values are. Meanwhile, real SQL complexity is a thing, right? That what we just saw a second ago was a toy example. Real SQL examples typically involve more complex queries, whether they be with clause or whether they be where clauses and some other things, but most notably joins. So we start joining a lot of stuff in realistic SQL queries, and okay, we join and join and join and join and join, and now we have all of these table aliases, and we typically want to abstract out these joins, right? Because we want to have these queries that have this stuff here, and we want to abstract the joins out into some kind of function. So we abstract the joins out into a function, and here's the abstract function. Okay, great. Except for the fact that we're assuming here that this table U, that this actually is existing from somewhere, right? We're assuming that this was coming from some table that has an ID column on it. And then we're assuming that none of these aliases are being used in other places, right? So, okay, fine. So that's how we compose our SQL. And this is, right, Jdbc has exactly the same issues. This is very, very, very easy to get wrong. The second that you have any kind of real complexity in your SQL. So, okay, how do we solve this, right? Well, okay, fine. Also, sorry, we need to, the other thing that we need to assume is these are other aliases that are coming from inside of this joined composition here. We have to assume that they exist. Okay, how do we solve this, right? What do we do about this? So ideally, we'd be able to just do this in the SQL, right? We have some kind of person or robot or troll or some kind of thing, and we want to join a bunch of permissions to it, roles and permissions, right? All security databases are kind of structured the same way. You have You have a users table, you have a roles table, you have a permissions table, and they're all mapped together with a many-to-many mapping. Thank you. Thank you, SQL databases. Thank you. Thank you, 20 years of SQL databases. That's how you do it. Okay. Right. Well, presumably our users could actually be three tables themselves, like we had in this example, people, robots, and trolls. So we need to join those to permissions, and we need to join those to roles and permissions respectively, and we need to go through two many-to-many mapping tables in order to do it, right? That's the query that we saw before. So we've got a bunch of joins here. What we wish we could do is just say, okay, we know what to do about joining the roles and the permissions. Whatever table you want to join onto these, if you've got an ID column, you can join it, right? This would be a proper functional interface for that, right? You pass the table in, you get back that table joined to these other things, right? Right? You pass it in. You pass in people or trolls, right? And then you get back this thing that into which you passed in that table, right? Except for the fact that databases can't do it, right? There is maybe like one database in the world that can do this, and it's not part of any official SQL spec. Like I think MarkLogic can do something like this. With Postgres, you can use any element, but it's not typed. So you have no guarantee of anything. Bottom line, SQL databases cannot do this. So you cannot compose like this. Query composition in SQL databases actually doesn't exist. And that's the problem. And ultimately, that's the problem that Quill wants to solve. Quill wants to solve this problem of query composition. How do you actually have a function into which you can pass a table, and then that table can join a bunch of stuff onto there and put a bunch of stuff onto there. And that will give you the API that will allow you to be sane. And in a corporate environment where you can potentially have hundreds of variations of this thing, the reality is that unless you're able to provide an API like this kind of joining of roles and permissions will result in hundreds of queries. And if you have this kind of API, it is not going to be hundreds, it is going to be dozens, or potentially even under 10 if you really get it right. So this is the point of Quill, to be able to give you this kind of sanity. Now, right, there's what happens, right? You pass query of person inside of this function, and there's the SQL query that comes out. So it composes it and produces the SQL query, right? So you put in some kind of table T, join the user roles table, join the roles table, right? Because we need the two intermediate user role, and we need the intermediate user role and role permission because it's a many-to-many mapping. Wonderful. All sorts of stuff that we really don't want to care about, but have to, right? And then join the permissions table, right? Now, we can also do left joins, right? You can do left joins in your for comprehension. This is kind of cool. I don't think that Slick can do this, like to this day. Slick can do query composition and for comprehensions, but they can only do implicit joins. They can't do
such a nightmare.
Explicit. I'm sorry?
It becomes such a nightmare. It's so painful.
Yeah, because right, totally. Yeah, because you need to use the applicative API, and you need to have you need to nest the applicative API. You need to nest it over and over and over and over and over again in order to do that. So we can do left joins and right joins, and we can mix and match inside of the for comprehension. So, oh, by the way, left joins is option, right? Because it's an optional, right? If you actually use SQL, you don't have an optional. So as a result of the left join, you get a regular table, but any of the columns can or not be null if you're joining, right? Because really, when you're joining something, the whole row can be there or not there. But of course, in SQL, they don't have a way of expressing that. So, okay, right. So this is just optional. These things are optional when you're joining them. So, okay. This is, and by the way, we can also do implicit. We can do implicit queries. If you just use ifs, this is an implicit query. Okay, so essentially Quill is like your SQL Swiss Army tank, essentially. And that's what you do. You compose, and then out come your compositions. Now, right, Quill gives you your query composition, right? Zio gives you your effect composition, right? Quill does the query composition, Zio does the effect composition. And that's how you combine them. You compose your query, you do the .run, then you've got your Zio effect. Now, the other important thing to understand is that your queries can be quite big, and you see this with Slick. Your queries can sometimes get huge if you're dealing with large corporate databases. And the problem is that if your query composition system is runtime, at the end of the day, you compose and compose and compose and compose, and the SQL that's coming out, you really have no idea what it is. You have no idea what it is. You have no idea what it's going to look like. And that's
a question, Alex. We got
sure,
one from,
sure, go ahead.
Dorn.
Can you go back
please. To 2 slides ago, I think. Dom Dorn was wondering how does Quill figure out which columns should join on in a person, troll, and robot?
The roles and permissions of, right? The roles and permissions of, let's look at it. There we go, right? So in fact, yeah, let's look at this example. This was the first one, right? So query user role, right? This is the UR is user role. We should probably like do this in the live code and actually go through these one by one. Hopefully we'll be able to do that in a couple of minutes. This is user role. So you're joining the user role and you're saying user role.user foreign key equals to the table of the ID. And in this case, if this is going to be a user, it's going to be user.id. If it's going to be robot, it's going to be robot.id. If it's going to be troll, it's going to be troll.id. In this case, I've decided to write this with structural typing. You don't have to do it that way. You could do it with interfaces, or with traits. You can do it in a couple of different ways. Or you can actually even pass a joining lambda into this. So you could be like, oh, this is a lambda in which I pass in the joining function. So there are a couple of different ways to do that. But the columns, right? So you join the user role onto, say, let's say that we're doing person, right? We're joining user role onto person. User foreign key equals to person.id. So in that case, right, we're using person here. We're using person here. User role UR on user role dot user foreign key equals to person.id. Right? And then we keep going with that. We say role, join role on the role.id is equal to the user role.foreign key, which we got here, right? UR is coming out of here, right? So that's what we've got over here, right? Join role R on role.id equals to user role.role foreign key, right? So user role here comes from here. So we join role onto the user role. We then continue and we say, okay, next, how do we join the roles to the permissions, right? We need another intermediate many-to-many mapping table. So we have a role permission that we call RP, that we then join on the role that we've already joined up here, right? We're doing that right here, role permission dot join role permission. We then take the role permission by the role foreign key, join it to the role table that we just joined over here. Okay, so we've joined that. And then we join that on the ID of the role, right? That's coming from this R right here. So join the role permission RP by the role foreign key. And then finally, we have the permissions table. We join the permissions table onto this last table, role permission, by the ID. So permission.id is the role permission foreign key, the role permission foreign key that to the permissions table, right? So that's the same thing down here. We join permission on permission ID to the role permission table up here, right? So you have this two many-to-many mapping tables, right? So user role maps users onto roles. Role permission joins permissions onto roles. And so that's essentially how you reproduce many-to-many mappings in databases that don't have such a concept. That's how you have a many-to-many mapping. You have these intermediate tables that do joining links both ways. So that's how we would do it. And again, like every single security database practically is structured this way. In fact, it's hard to believe, but many-to-many mapping tables are so popular in some databases that in a lot of places, they just have them where they don't even need them. Like in a lot of places, you don't even need a many-to-many mapping table because you can just, let's say you have person and you have addresses, and each address can just have a foreign key to its owner. But no, they'll still have a many-to-many mapping table. And they do this because, oh, one day we might want to join addresses to people many-to-many. Like that actually happens. That is a real thing. Yet another reason why you want to introduce levels of abstraction around SQL interactions. Anyway, okay. Any other questions?
That was it. And this is actually pretty fascinating because my use cases with Quill have been quite simpler, but I've just used it for like the ergonomics. But I didn't even realize that, yeah, this solves a huge issue about query composition, and that probably is its motivating use case. But I mean, you get these sub use cases of just, it's terser, more concise, and a little easier to use as well as opponents. But this is huge.
Yeah. That's the other funny thing, because sort of a lot of people see, they go to io.getquill and they see some of those simple examples. And it's like, okay, fine, this is simple examples of joining stuff. We can, simple database example. But it's like, no, the purpose of this stuff is to scale to the hardest use cases that you can find when selecting data, like the most brutal situations that you can run into. Okay. Should I keep going?
Of course. Yeah. We're good.
Right,
yeah, keep going.
Let's keep going.
Yeah, I'll probably maybe in like another 15 minutes. Do you want to switch over to live coding? So we have like a good half an hour to look through the code examples.
Yeah, I think so. We're almost done. We're almost done. So what I wanted to address, okay, so the problem with things like Slick is that you write all of these query composition things at runtime, and you kind of don't really know what the query is the query that's gonna ultimately come out. And typically the query that ultimately comes out is some monstrosity like this. And you find this in your production code. And by the way, this is formatted. You find this unformatted in your production code. And because you don't know what variable represents what, right? Like what is this? What is S176? What table is that? This is production. And when this fails, it's like, you need to debug this ASAP. This is not something that you want your DBAs to like yell at you about. It's just, this is not a pretty picture. So, right, like what the heck is this? So, and then DBAs typically don't like stuff like that. They don't like really weird stuff that is clearly generated that is obvious that nobody understands. DBAs ideally like to know what the heck you're going to be doing on their database ahead of time. Like that's what they would love to know. Like, what the heck are you going to do? And they can tell you, oh, here are the indexes you need to create in order to make that performant. So ideally, we want to generate the query at compile time. And this is what Quill does. Quill uses macros in order to generate the query at compile time, so you know at compile time what it's going to be. Right, and this is what's coming out. This is what comes out of SVT. This is what comes out of Scasti. You actually see the query that it'll generate. And you can actually even go further, and query probing allows you to actually execute the query, let's say on some QA database or on some embedded database. You can actually execute it at compile time. Technically, you don't execute it, you prepare it, but it's close enough. And so you know ahead of time what you're doing, you know how to optimize what indexes, et cetera, et cetera. Now, okay, here's the thing, right? What about variables? What about runtime variables? You don't know what their values are actually going to be, right? This name thing is coming externally. You can't, how do I generate a compile time query if I'm using an external variable that is only known at runtime? How do I do that? Well, that's why we have this lift thing. And what this lift thing does is it says, this is an external variable. This is a variable that we are bringing in from some external system into our compile time SQL query. And then it knows that, okay, it knows what to do with this typically. And in fact, we can, if these types are things that SQL doesn't natively support, if it's not just strings or Booleans or ints or longs or shorts or floats or dates, right? You can actually write encoders. So you can write an encoder for some data type. And if you can figure out how to encode that using the Jdbc APIs or the Cassandra APIs, if you could figure that out, then you can actually use it inside of this lift thing. And so we lift it into this query. Here's the thing, though: you can lift a whole lambda. Not really. I mean, not lift in the sense of encoding, but you can quote a whole lambda. Excuse me, that was a mistake. You can quote a whole lambda. And so what this lets you do is, this is actually the ultimate query composition operator, is that basically you're taking a whole lambda and you're saying, this is a fragment of SQL code that will eventually be evaluated. And so at this point, you don't even need to do lift on this variable anymore, because the whole thing is quoted. So in fact, this is a macro inside of the quotation. So then, okay, one other problem. This was in Scala 2. In Scala 3, this is a little different. But in Scala 2, if you're assigning a variable to a query, you cannot give it a type. You cannot, we call it a type annotation. You cannot give it a type, essentially. And the problem is that, well, you can, but it will become a dynamic query. We will not know what this is at compile time, because we don't have type refinements on this variable that allow us to actually know what it's going to be at compile time. This is a limitation of Scala 2. In Scala 3, we use inline def in order to get around this problem. So in Scala 3, it needs to be an inline def. This thing here needs to be an inline def before you run it. So this would need to be an inline def in Scala 3. But in Scala 3, you can actually add the type annotations and it'll work just fine.
And there's no quoted wrapper either, right? It's just
Yes. In fact, you have a choice. You can add the quoted wrapper in the inline def, but you don't have to. Cool. So that sort of begs the question of, do we really need a quoted wrapper in the first place if you have inline defs? And the answer there is, well, if you want to do dynamic queries, you have to. And that's sort of the question. Sort of, do we get rid of quoted completely? Or do we keep it because there are these dynamic queries? And that's a question to ponder about for the years to come. But anyway, yeah, in Scala 2, it uses these refined types, which is why if you add this type information here, it basically removes all of these type refinements. And this is what we do to generate your compile time query. Now, the other thing is that there are other things that you can do that kind of don't allow us to understand things at runtime. For example, if you introduce some switches that will decide things at runtime, like if you want to figure out what query you're going to be executing from some runtime condition, we cannot give you a compile time query because we don't know what this is at compile time, right? So we actually can't give you a query from that. In Scala 3, if this is an inline def, and if this is an inline condition, and if this is an inline if, we actually can. Because we can, assuming that we know what this thing is, that this is some static constant or something, assuming that we know what this is in Scala 3, we can actually make this work. So more fun stuff. But in Scala 2, it's going to be a dynamic query. So the question is, in that case, how do you compose things? What's the operative paradigm, right? If you need two different things, how do you compose them? So the way that you do that is you try and save any kind of runtime choices that you're going to need to make until you need to execute this actual run call. So if we need one query or a different kind of query, try and do that as a condition at the end and put different kinds of run operators on it. Now, that's not always possible. Right? Because, you might want to filter on 8 different types of columns, and you only know at runtime which column to filter on. Or you might want to sort by or group by different kinds of columns. And you don't necessarily know until runtime, because that's coming from some variable arguments coming from an HTTP server. So you can't always know this. But in many cases you can. In fact, I'm not going to be talking about it today, but there's some very cool stuff coming from integration between Quill and Caliban that will actually let you filter and filter as well as turn off or turn on any column in a table, and be able to do that with a compile time query. There's some fun little stuff with SQL, and thank you very much, Pierre, for helping me out with that. Hopefully in a coming presentation, I'll introduce that stuff. So that definitely pushing the boundaries of the kinds of queries that you can know at compile time. But we do support it. We do support dynamic queries. This is not, it's not a problem for us to do, but it's just not ideal. So, okay, that's if you delay the kind of logic that you need to do, if you delay your runtime logic essentially to after this run function, that's one pattern that you can use of still having dynamic queries. So in the past, you might have used Doobie, and you might have used Quill with Doobie, and you might have integrated that into Zio. Typically, it starts with something like this, right? And then you might have had something like that, and you might have used composition operators for it, and you've used Quill with Doobie before, right? And you've then had to create a transactor, managed transactor coming into Zio before. So you might have had to do something like that. And this works. This is a working approach. There are a bunch of different instructions on how to do this. Directly integrating Quill and Zio is substantially easier. All you have to do is call this run function, and you can then directly compose. You can directly compose with Quill queries into ZOFX, and that's how you would do that. And I guess that's it. Let's get to the live code.
Yeah.
All right. Let's see. I'll share my screen.
So I will be right back.
Sounds good. Meanwhile, I will explain what we at least have here in this file. So we've got just basically everything we need in one location. We have our main application here, which is our ZO app. And we have this get people accessor that's going to get us a list of persons. And we have a live implementation of this, which actually uses Quill. So we have the run method, we have a query of person, and then we're providing our data source, just as Alex described. And so we can run the whole application by calling get people, injecting our live implementation and its transitive data source dependency. And then we're going to just print the results. So here we actually have some sample data set up. So when we run this, we get a list of Jack Ripper, Vlad Dracul, and Joe Blogs. These are all Alex creations, obviously. So yeah, while we're waiting for Alex to rejoin as well, I can probably go a little bit deeper as well. So this is sort of the query that we're talking about. And if I wanted to, I could abstract this to say, you know, all people. But if I wanted to actually get this to work, let me try to run this. This might give me a warning. Yeah, so there's a couple of issues here. I think I need to quote this. So using the quote method, if I want to abstract queries, we have to quote. And now it works. So because it's quoted, it's totally fine again. So you have the ability to abstract these things. And also at build time, we're getting listed out for us here the queries. So it's select ID and first name and last name and age from person, which is pretty nifty. And then we can see that let's not get everything. Let's maybe filter. Let's filter if the age is, what are some of their ages? Let's take a look at what we ran there before. So yeah, Dracul is really old. So let's try to only find vampires real quick. So let's do filter is greater than 100. And we'll run this. We should only see Dracul, only the vampires. There we go, 321 years young. And if we look at the build, we'll now see that our query that's being generated is very readable. The same thing, except now we have this where clause on the end. And I think Alex is back, so I'll let him guide us from here. Let me go to my terminal real quick and see. No. Okay. Alex, are you with us? Alex,
where are you?
help us, save us.
You're our only hope.
Oh, hey, Alex. So then I could rename this now probably to all probable vampires. Or just really old people, but you know, they're probably vampires. And yeah, and if I add the type annotation, which we shouldn't do, I believe we get a warning here at build time that says, hey, dynamic query. And so that can give us a clue to remove that. But yeah, even if you don't use this sort of the, let me just inline this for now and remove the extra layer of quoting. Even if you don't use the query abstractions, like it's just very nice to be able to write queries such simple syntax. And it's you know, if you've used Slick before, it kind of is a Slick-esque API, but even nicer, and without all the crazy table definitions that you need to do. And clearly, you get better composability if you ever tried to do a series of left joins in Slick. Not pleasant. Can you hear us, Alex?
Yes, I can.
Oh, good, you're back. All right.
Yeah, you're doing such a good job. So, why don't you continue?
Well, yeah. So, I'm not so familiar with the data model, but we can get more complicated. So, I was just describing how we have this an abstract service, a ZO, you know, following the service pattern. We have a service that represents our API. So here it's more actually we're doing get vampires because you've made some very old people. So we have this API. We have a live layer that lifts this live definition into a layer, which will just translate its dependencies into layer dependencies. And then we implement the methods by just basically writing them against the run method and the query method, which I should mention, by the way, we get by importing this Quill context.
Yes.
So here, the only boilerplate you really need is we have a Quill context. This is our own object that we made that extends the Postgres ZO Jdbc context. And then we have, I just happened to put this here. You don't really need to put this here, but a data source layer. So this is going to get us our data source, our Hikari connection pool. And we need a corresponding application conf. And so right now it's very simple. I just have a database name and the data source class name. And that prefix here in this conf is going to be found by our by this right here. So the database prefix needs to line up with the little nested application conf syntax. But yeah, that's all it really needs to. Oops, this needs to say get vampires now. And we can just run this pretty simply. Yeah, and then the very cool thing is that, maybe it's a little boilerplate here. We've got to inject it, but normally this would be your entire application under here. And your entire application would just need a data source. And so you'd provide just some simple services for everything your app does. So this boilerplate does not scale linearly with the complexity of your code. It scales super logarithmically. It's going to basically not grow much. We're just going to have to, as we add more services, add some more service definitions, user service, etc. But our code can grow in complexity beneath this. But yeah, do you want to build some more complicated queries, Alex?
Yeah, let's try a few fun things. So first of all, let's have a look at, let's introduce a service, and let's say that we have, let's introduce a service, and let's say we have the service is, let's say, an age service, right? And an age service is needed as part of the data service live. And that age service basically just provides an age as a dependency. And it could be a case class, right? It just has an age or something like that.
Oh, okay, so this is just some default age. Let's go like this. So maybe this is the
yeah, exactly.
Okay.
And so that goes into there, and then we get the age from that, and then we take the age and we lift it from the age config.
That's okay. So this could be a sort of a vampire research service.
There we go.
The suspicious age.
Yes,
okay.
Precisely.
Suspicious age. Okay, and I'll just have this return an int for now. And yeah, maybe I'll just make it a case class because you can do this as well. Doesn't really matter for these types of nodes. All right, so we have vampire research, and this needs the age config, the vampire research facility dependency. Okay, and so yeah, we would want to, instead of doing 100 here, we'd want to say vampire research suspicious age. However, I think we're going to get the problem right. We're going to get a compile error saying that, oh yes, we cannot have this free variable. So we need to, as you mentioned, I believe, lift this.
Yep, exactly.
Okay, and now hopefully if ZO magic works here, it's going to say that, yeah, we're missing vampire research for data service live. So let's create a new Z layer succeed vampire research. And let's say the suspicious ages, let's just go 40. Let's pretend like we're back in the Middle Ages and anyone who lived over 40 is probably a vampire at this point and would be hunted and killed. So now we have Jack the Ripper. Ooh, might be a vampire. And certainly the extremely senescent Vlad is a vampire.
Awesome. So this is great. This is really great to be able to compose this way, and to be able to just read something essentially coming from a different service, and then to be able to provide it. So the thing, let's see. So the first thing that I want to mention, why don't we go over into the Quill con? Why don't we create another library? Let's say we have a function library into which we import the Quill context, and take this query here, and move it into a function library.
So should this be an object or a trait?
An object, yeah. Yeah, we can make this a static object. Yeah.
Okay, cool. So I'll copy this for now, and I'll go into the Quill context file for now. I guess we could put it somewhere else, but just to have a couple.
Yeah, we can put it in there, but it specifically should be a different object from the Quill context.
All right, let me just call it queries. Is that okay?
Queries. Okay. Wonderful.
So let's do this. So I will take my query here, and we'll throw it in this. And I think we need to import the Quill context, right?
Yeah.
And then we can probably, well, this one's interesting because we want to lift some age. We don't want to have this be dependent on the vampire service, I don't think.
Yeah. So let's create a method that takes an age.
Yeah. So let's say filter get older than persons older than age.
Perfect.
And we'll do this, and I believe we would need to quote this, right? So we'll quote our query.
Yep.
Great.
And now let's import. Well, we need to know. Well, try to compile it. Let's see what happens.
Okay. Well, first, yes. Let me go back, and I'll say queries.person older than. I'm not sure if I should have to lift at this point, or I could just do vampire research suspicious age.
Nope, you don't need to lift at this point. Oh, you imported Quill context, so yes, all of that should work. All of that should work. Yeah. And it okay. So very cool. The thing to note here is that we really haven't done much to extract out the Quill query out into this object. We just imported the context and everything worked.
You don't need a cake pattern. We don't need a cake pattern. We don't need a series.
Yes, exactly.
Which is brilliant.
For every other thing, like if you were using the Monix contexts, you would not be able to do it this simply. Like you would need to create a cake pattern, and you would need to basically queries would have to be a trait, and the trait queries would have to extend the Quill context. And then back in main.scala, when you declare your context, you would have to tack it onto there, and it would just be a big mess. But because Quill context can be a static global, and we get that because we have this provide data source from Zio, it is just that simple to be able to abstract your queries. And the same thing is true of Quill Cassandra, and hopefully every other Zio context in Quill that we will implement. So let's see, what should we do next?
Want to get some permissions for these vampires?
Huh?
Want to get some permissions for the vampires? Do some joining stuff?
Yes, but before that, I want to do one thing. Okay. Persons older than, let's take age, and let's move age into the quote. So quote will be a lambda of age to query person filter age greater than.
Do you have potential? Could you write that? Because I'm not entirely sure. Yeah.
So there. Now.
Yes. Cool. And then we don't need the lifting, right? If I'm correct.
Yep. You got it.
Yeah. So that's
yeah. I think it might even give you an error. Let's see. Let's try to lift it, and then let's see what happens.
Okay. Let's lift, and I will run.
That might give you a weird error.
Okay. Yeah. Error when emitting queries value age. Okay.
Yeah. So first of all, so let's take that. Let's try to run it again. And now we'll have another problem because now, well, we need to
lift here.
Yes.
Okay, interesting. So we need
this is another fun thing where if we want to push the query composition out to the data service live, right? If we want to push it out to there, we can push it out to there. If we want to have more stuff be inside of queries.scala, we can leave it there. So wherever, for the sake of our application, wherever it makes sense for that logic to live, we can put it there. We're not constrained by those kinds of things.
So what is the difference? I mean, they seem to be pretty equivalent. I mean, where you have to lift is slightly different. I sort of almost prefer lifting internally because then you don't have to lift at the call site. It's more like calling a method. Are there other sort of trade-offs though besides where you lift?
Well,
I'm sure there are many details, of course.
here's the thing.
Mhm.
This, you can actually find out the difference by doing .ast, and you can actually find out what the syntax tree is going to be. This actually does the function evaluation inside of the Quill macros.
Okay.
Because remember, quote will take all the stuff in here and it will parse it. And so this becomes parsed as a function.
Sure.
And so here's the thing. The first part is, well, there is this performance thing. The function will already be evaluated.
I see. You're not actually calling anything here, and when you apply to this, it's just okay. So, would you recommend doing things like this for the most part when you're making these higher order functions? These higher order queries.
It depends on your application. I think a good starting point is to do it like this. Move it up to the function if that's what makes sense for you.
Mm-hmm. Could this be a val now? Oh no, it has to.
It could be a val. It could be a val. Yeah. Yeah.
Cool.
And what's fun about this, and this actually, so here's the thing. Well, there's not much of a performance difference between making it a val and a def because quote has already staged all the computation, so there's no serious performance benefit from that.
Yeah, sure.
But you could try it. I think that putting it inside of the quote as a first approximation is better because then it's just less confusing where you need to do the lifting part. Typically what you want to do is you want to do the lifting part on the API surface, as opposed to if you start having to put the age inside of the person's older than, that can make things messy.
Yeah, I think consistency is good. So yeah, let's just, like as a best practice, maybe just do it like this and try to be consistent because yeah, otherwise it's like sometimes it looks like a method, but sometimes you don't lift, sometimes you do lift.
Yeah,
I think picking one style and sticking to that is probably a good recommendation.
Exactly.
For sure.
Cool. Yeah. There are a bunch of caveats in Scala 3. Like in Scala 3, if it's you can actually do this, and you can actually do that, and if you do this, and if it's inline, then that is actually the same thing as putting it inside of here. That is actually the same thing. And in fact, if it's inline, this has to be inline.
Sure, everything has to be inline, and then you don't need the quote and everything.
Exactly. Yeah.
Scala 3 is going to make everything a lot simpler, obviously, and less of these hacks. But the hacks are minimal, and I'd say worth it altogether for the benefits.
Yes, exactly.
All right, awesome.
So yeah, let's try to join some stuff. Let's see how we could do that.
Want to start with like get vampires with their addresses or something, or
yes.
Okay, get vampires because we want to hunt them down, with addresses. Let's see, what should this look like? So this is be an IO of a SQL exception and a list of, should we do like just a pairing of a person with an address?
Yeah, let's do it like that.
Okay. All right. So yeah, how should we start here? We probably want to run. We want to provide our environments.
Yeah.
And then internally, we want to do what? A for comprehension? Or should we start simpler than this? Okay.
Let's do a for comprehension. I would do a for comprehension. There are other APIs, but the for comprehension API is so simple that you might as well start from there.
Okay. So here I can sort of, do the queries dot persons older than, and lift that same thing to get just the vampires.
Yeah.
There's my D. And then I can get the address by doing what? Query.
You need make sure to lift it.
Oh, yep, totally. Lifting it here. Left, not left. Lift.
And by the way, if the person's older than if it was like we did it before with a function, you would not be able to do it like this.
Oh, really? Okay, interesting.
See, you can try that, right? That's the other reason why you would want to put the age inside of the quotation for the person's older than, because if you don't put the age inside of the quotation, it can get pretty nasty with the composition of that and other things.
Okay, so it sounds like writing your higher order functions like this is the way to go then.
Yeah, yeah.
Okay.
So query of address and then do .join. And then A2, typically you want to give these things actual aliases because the aliases that you use will actually go into your generated queries.
Okay. So A2 we want to say here?
You can do A, but that's fine.
Yeah, I'll go verbose and say address dot
address, owner FK equals to v dot ID.
And I'll even change that to just so we could see the niceness of the vampire.
Yeah.
This would be address. And then we want a tuple of vampire and address.
Also notice that you can do a regular equal. You don't need triple equal. You don't need any funny business here. Regular equal works just fine.
Let's get their vampires with the addresses. Let me add this to the actual trait as well. So lovely. Let's try get vampires with their residences. Hopefully that works. Oh, we got nothing. Maybe these people don't have addresses.
Yeah, I think we'll have to add some of these things to our model. I don't think we have any addresses inside of our database.
Oh, there are a couple, but I don't know. The owner F keys or do they belong to? They don't. Maybe they don't belong to people. They belong to trolls. They belong to trolls. So let me actually rename this to. So the owner FK. Let me see. Let's modify this table. What does that foreign key represent? That was just an integer for now. So let me change it.
I actually do not have foreign key constraints on any of these things. So we can just modify them.
There we go. So let's try that again and get some homes. There we go. Yay. So Vlad is on Winter Street and Jack the Ripper is on Summer Street. Lovely.
Yes. Okay.
What if there were more than one addresses per person? Is that something that we could do? Oh, that's sort of, I think, the next, maybe that's something we have to deal with at the user level.
Add it to the database. Go ahead.
Let's give someone 2 addresses. So let's give Vlad multiple addresses. He's got to move around a lot between summer and winter. Spread his victims around or what have you. Okay. Well, I think we're just going to get currently, let's see, Vlad. Yes, so we got 2 addresses for Vlad now. But it's going to, so it's not, we have to manually sort of group by. I think that's kind of the other.
Yes.
That's just what you have to do outside of this. It's SQL gives you a tabular API. It doesn't also deal with that problem.
Exactly. So, we did a foreign key join and all of that stuff will work.
That's pretty fancy.
Yeah, and that's what I would say. Basically, Quill has a different API. Quill has an applicative API for joining. But honestly, the for comprehension is just so simple that it's not even, you don't really even need to bother with the applicative APIs, I think.
Sure. Yeah, no, and that's super nice because other libraries don't really have something as lovely as this. And let's see, just to look at the query, it's getting from all these person properties, X1. Oh yeah, and that's only because I probably named this poorly in here. I just called it, that's why it's X1, right? But if I did person, so maybe that's a reason to actually do these more verbose versions because now we're going to get a much nicer.
Exactly.
Let me make one change just so it recompiles and spits that business out. All right, here we go. So, no, build, come on. So now we're getting person ID, person first name, person last name, person age, address owner, foreign key, address street, address zip, address state from person, inner join address on address owner F key equals person ID where person age is greater than question mark. So that's super readable. Is there also a way, I saw in someone's app I was helping, is there a setting to print out or to save to a file somewhere all of the queries?
What version of Quill are we using? Are we using 3.12?
Yes.
So do go to the SBT settings.
Okay, I'm here.
No, the actual SBT runner. So you have to if this on a Mac, you have to do like command comma, and then you have to go to SBT.
Oh, SBT. Okay.
And then go to right. We're compiling with wait, hold on. Are we compiling with SBT?
I believe so.
Okay.
Or maybe not. Maybe I could try to run it just in the terminal. Let's see, SBT.
Hold on. No, can I see 1 second? Let me just quickly see. Let me just quickly see. Yeah. Okay. Fine. Can I quickly see the settings again?
Oh, sure, of course.
Okay. Download SBT sources. SBT shell use for builds. Use for builds and use for project reload. Let's do both. And then let's do okay. And then let's reload the project. And then let's run the application.
Okay. Yeah, because I saw something fancy before, and I can understand that it's a pretty cool bonus.
Yeah, there's the application run, and let's compile it.
Okay, compiled.
Okay, and let's go to the SBT shell because that's where everything is coming from. You'll see SBT shell on the bottom. There we go. And make a change to
this file.
Make a change to that file. Yeah, do that, and then let's recompile. And then we'll see the same query. We'll see the same query. We'll see the same two queries. Now go back, do command comma again.
Okay.
And then under VM parameters, do -d. Let me double check this. -d capital D quill.log.query.
Like that? Do I need a space between D and Quill, or it's all good?
No spaces. Just Quill. Oh, sorry, quill.log.file. Quill.log.file.
Quill.log.file
equals to queries.txt. Or sorry, queries.sql. Let's do it like that. So then let's.
Oh, does it work? Oh, sorry, something that exploded. The quill dot what dot file?
Quill.log.file
equals queries dot
SQL. Yeah. Apply. Okay. And now you need to actually stop. You need to actually stop SBT, and you need to relaunch.
Okay.
And hopefully, and let's modify our file. Just add a comment to it or something, because it won't recompile unless you manually modify it. So let's see. There we go. Let's force it to compile. And then let's reload our, we should see it now. Let's reload our Quill2 directory. Let's look at our sidebar.
Yeah, I don't see anything there yet. Maybe I could reload or reboot or something, or just compile it from here. I wonder what would have cool equals to. What would get those parameters going?
That.
Oh, I can see something.
There it is.
For some reason, everything blew up, but
1 second. What happened there?
Let me remove that cool too. Maybe that blew it up for some reason. I have no idea why.
Yeah.
Yeah. That blew it up. But we have queries now. It's working.
Yeah.
And yay!
So this is exactly. So this uses and if you all you have to do so do let's see, you're running Postgres, right? Click on configure data source. And yeah, plus let's go to PostgreSQL, right? And then you can do your download missing driver files, etc., test connection, wonderful, voila. And then you could go back to, and then you could do okay, fine, change dialect to global dialect Postgres. Fine.
All right, and now we can.
And you should be able to do just run and Postgres at localhost. Not the other one, Postgres at the local. Yeah, let's try that.
Oh, and then I give
then
it.
you need to enter, because there's a question mark there, you need to enter the parameter.
Which would be, I think, an age, one, or age. What do I have to do? Person.
No, 1, 2, 3.
Oh, there we go.
Yeah.
Oh, age is greater than 1, 2. Oh, so I just need to expand the window. Okay, so wow, yeah. For the parameter, you do this, and then, whoa.
Yeah.
So that got their addresses, join on their addresses, and then this one I can just, yeah. So they all involve getting the age. This one will just get the persons, and I can do age is greater than 1. Execute, get everybody. That's super cool.
Now here's a fun thing. Let's go back to let's go back to queries.scala for a second.
Mm-hmm.
Now, we're using, what are we using? 2.13 in this case?
Yeah, 2.13.7. Yep. Let's
do final val large age.
Large age, okay.
Equals to, let's say, 1, 2, 3, or 100. Yeah.
Okay.
Now, let's put large age instead of age and recompile.
In here?
Yeah.
Should I keep it as a function?
Yeah.
Do I need to lift this?
Yeah, keep it exactly that. No, don't lift it. Don't lift it.
Okay.
Don't lift it.
And
just
run
large age. And let's try and compile it. Yeah, you can compile it in IntelliJ. It'll be fine. Now, let's have a look at the compiled query. Let's go back to the SVT shell.
Okay. Oh.
Yeah, there, SVT shell. Let's have a look at the query.
Okay. Maybe it already did. Oh, it already would have done that, right? Yeah. So let's see. Okay.
Down. We already passed it.
Oh, I see.
No, further down.
Aha.
So here's the thing. When you do a final val, it becomes a literal singleton starting 2.12, I think. So if you do, and this is actually one great way of doing enums with Quill. If your enums are literal singletons, then you can actually put them right into the Quill queries without having to lift anything, and they will be interpreted as constants.
Oh, that's cool, because the type of this is basically 100, right?
Yep.
Figure that out.
Yeah, so and it figures that out.
Singleton type. That's cool.
Does that only work for, things that have singleton support, like strings and ints and whatnot?
Correct.
Okay.
Correct. Yeah.
For Scala 3, if you have an inline def, something with that, somehow
in Scala 3, you still do not need an inline def for that.
Okay, cool.
It works the same way in Scala 3. You keep this a literal singleton in Scala 3. It works the same way. So it doesn't need to be inline. You can, if you want, you can make it an inline. It doesn't hurt, but it's not necessary. And
so I think one of the use cases I've heard you mention for this, and obviously we have these builds before, but you could give this to your database administrators, and then they can optimize their tables for the access patterns that you use, which is pretty sweet. Instead of I can't imagine trying to do that in some other way.
Yes.
And it's very convenient. I guess you could add some sort of agent or tracing to your application that logs, that tries to intercept queries. But this is all the compile time, which is insane and very, very fancy. Well, we're coming. I think we're at about an hour and a half. Would you be willing to join us again next week for some more advanced query explorations?
Sure. Yeah.
Awesome.
That sounds good.
Yeah, maybe we could look at some more complicated situations as well. But also,
let's
I think
Proto
Quill is coming. Oh,
Yeah.
There's a question on Discord. Thank you. Let me check out the Discord. Let's see what we got here.
Yeah, I think we have one question.
Oh, yeah.
What
Do
if
you
I
even lift
join
Pro?
tables
I had
at
him.
the same time?
I'm sorry?
What if I have to join two tables at the same time? How does it handle conflicts and aliases?
So there is a de-aliasing step in the Quill transformation phases. So typically if you have queries that have aliases in nested contexts, and we could try that actually. We could try putting a in fact, let's see, what do we have in that? What do we
Here
have?
I just did this thing of where I'm joining address twice and I gave it the same name. I'm guessing
Yeah,
that's kind of the
and
situation.
it understands that, and it
Okay.
can where needed it can de-alias.
Yeah, it seems like it worked. Let's take a look at the actual generated code. Well, I can go to my queries file, I believe. So we have a couple of addresses, right? Or maybe it simplified it as well. I'm not sure.
So yeah, so we have that. Now the interesting part is what. Yeah. That's fine. That's fine.
Mm-hmm. Oh yeah, because there's address one, so it de-ambiguified it.
Yes.
For us. Yeah.
So we have address. We have ways of de-ambiguifying common things. If you do something really crazy, it might not work right. So please file a bug for that. There's a lot of thinking that I've had over the years about how to potentially change the
disambiguification.
Yes. I've had a lot of thoughts over the years about how to design that system better, but for most things it should work fine.
Very cool. Well, yeah, thank you. Maybe next time we can go into more some of the lower level stuff like configurable schemas and whatnot. Like what if your table's not named address and things like this?
Yes.
And the ways you have of doing that, which are quite nice.
Yeah.
Yeah, this is sort of the best principle. With the easy stuff is super easy to do. The common paths are almost trivial, but when you need to do more complicated things, you're not screwed. There's not a dead end. You just have to sort of go unpeel the onion layer by layer.
Yes.
That was super fun, Alex. That was a blast. Always is.
Yeah, my pleasure.
Yeah, thank you so much for joining.
Yeah, we'll see you next week, and we'll see everyone next week.
Good.
Probably at the same time as this one, a little earlier than usual. I'm glad we finally got some people. All right, bye everybody.
Have a good weekend.
You too.